In this lesson, we are going to use sine, cosine, and tangent trigonometric functions to find some unknown sides of a right triangle. So problem number one, the first thing we have to do is decide which function we're going to use, sine, cosine, or tangent. Start by looking at the angle that we have. So there's the 59. Are either of these the hypotenuse? No. This x is the adjacent leg, and this 17 is the opposite leg. Opposite and adjacent. Which trig function is that? That is the tangent function. So we're going to go like this, tangent 59. Alright, and we know that tangent of an angle is equal to the opposite leg over the adjacent leg. So in this case, the opposite leg is 17. Okay, opposite is the one that's far. And the adjacent leg is x. So tangent 59 is equal to 17 over x. What do we do when the variable is in the denominator like this? Well, this is the one where we can take that shortcut and reverse the denominator and the thing that's by itself. So that's going to become x equals 17 over tangent 59. Then I can just put that in my calculator. And I get 10.21. Nearest tenth, so 10.2. So x equals 10, wait, what was it? 10.21, yes, so 10.2. Alright, number two. Start with the angle. From the perspective of this angle, 7 is the opposite leg, and x is the adjacent leg, far and near. So again, that tells us we're going to use the tangent function. Tangent of an angle is opposite over adjacent. So tangent of 26 degrees should equal 7 over x. Alright, so this is almost the same as the last one. We'll reverse these, so this is going to equal x is going to equal 7 over tangent 26. And then I can just put that in my calculator. $14.4. Okay, last one. Looking from the 42 degrees. The hypotenuse is down here. So this x is the opposite leg, and this 19 is the adjacent leg. Alright, far, near. So once again, this will be the tangent function. So tangent of 42 degrees should equal opposite over adjacent. So x over 19. Am I going to do some swapping thing on this problem? No. That's only going to help me if the variable is in the denominator. If I switch the 19 and the tangent 42, I'm no closer to getting x by itself, so that wouldn't help. But what I can do is multiply both sides by 19, like this. That way these 19s are going to cancel each other out. And then I will have, so then I have 19 tangent 42 is equal to x, which I can just put that in my calculator, 19 tangent 42. 17.1. Okay. Okay. This time I have more than one variable to find. This confuses some students until they realize we'll just do one at a time. So just to make it obvious, I'm going to scribble out this variable for a minute. Just pretend like it's not there. So looking at this 57, the one I just scribbled out, that was the hypotenuse. So that means these two are opposite and adjacent. All right, from the 57, the 14 is opposite and the A is adjacent. Okay, opposite and adjacent. Which trig function is that? Well, it's the same one we've been doing over and over again. Opposite over adjacent, that is once again the tangent function. So we're going to continue on with the tangent function. So tangent of an angle is equal to the opposite leg over the adjacent leg. So in this case, that's 14 over A. This is one of those where we will reverse the denominator and the function because the variable is in the denominator. So this will become A is equal to 14 over the tangent of 57. So put that in your calculator. Okay, that's 9.1. Okay, so we found A. Alright, but we still need to find B, the one I scribbled out at first. So I need to go back, sort of start over. Okay, I'm still going to work with the 57. But I already found A, so I'm going to scribble that out this time. So now I'm going to deal with the 14 and the B. Alright, 14 is still opposite. But B is the hypotenuse. So which trig function is opposite over hypotenuse? Opposite over hypotenuse, well, that's the sine function. So that tells us that we will use the sine function. Okay, so I will say sine of 57 is equal to 14 over B. Okay, when the variable is in the denominator, that's when I reverse the equation like this. So that will give me B is equal to 14 over sine 57. So therefore B equals 14 over sine 57 is 16.7. Let's round that up. So 16.7. Okay, so if you have more than one variable that you have to solve for, just scribble one of them out. I like to go in alphabetical order, so I'm going to start with A. I just scribble out the B and do the problem as usual. And then I go back and I scribble out the A and I do the problem again. That's all there is to it. Alright, looking at number 16. We've got the 41-degree angle. See C and D. I'm going to find C first, so I'm just going to scribble out D so it doesn't distract me. So this is what I have. First of all, this was the hypotenuse down here, so forget about that. That means C and C and 17 are opposite and adjacent legs. The 17 is far, so that's my opposite. and the C is near, so that is my adjacent leg. Alright, because this is the hypotenuse. So opposite, adjacent, that is the tangent function. So I will go like this. Tangent of 41 degrees should equal opposite over adjacent. So that's 17 over C. When the variable is in the denominator, that's when I reverse the denominator with the function. So this is going to become C equals 17 over tangent 41. Okay, that's something I can just put in my calculator. 17 over tangent 41. That gives me 19.6. So C is 19.6. Okay, now I need to find D. I need to find the other variable. So let me uncover this. I'm not going to be needing the C anymore. Okay, in fact, I think I will go ahead and scribble out C this time. Now, 17 was opposite. C was the adjacent leg because D is the hypotenuse. Okay, so I've got opposite over hypotenuse. Which function is that? That's the sine function. Okay, so let's set up the sine function. So sine of 41 degrees should equal the opposite leg, 17, over the hypotenuse, which is D. Alright, once again, my variable is in the denominator, so we'll reverse the denominator with this function. So that's going to give me that D is equal to 17 over sine 41. Okay, so I can put that in my calculator. $25.9. Okay, so that is it for number 16. Alright, let's take a look at number 17. RS. So let's just take it one at a time. So I'm going to scribble out the S for a minute. S was the hypotenuse, by the way. So looking at the 36, that leaves 21 being the opposite leg. See how it's far away? Opposite is far. And R is the adjacent leg. Okay, because that's the leg that's near. Of course, the one I scribbled out here, S, is the hypotenuse. So, opposite over adjacent. Guess which trig function I'm going to use? The tangent function. Tangent of 36 is equal to opposite over adjacent, so that's 21 over R. The variable is in the denominator, so I will reverse these. So that's going to give me R equals 21 over tangent of 36 degrees. 21 over tangent 36. So put that in your calculator. 21 over tangent 36. That's 28.9. Okay, so that is R. So now let's go back and find S. So let's uncover that. Won't be needing that. That was the adjacent leg. Okay, so I'm going to scribble out the R this time so we can focus the mind. Alright, R was the adjacent leg because S here is the hypotenuse. So now I've got the opposite leg and the hypotenuse. Opposite over hypotenuse is the sine function. So I'm going to do sine, let's see, how much space do I have over here? Oh yeah, I'll just do it over here. So I'm going to do sine 36 is equal to opposite over hypotenuse. So that's 21 over S. The variable is in the denominator, so let's swap these. So that's going to give me S equals 21 over sine 36. I can put that in my calculator, 21 over sine 36. 21 over sine 36. That gives me 35.7. Okay, so that is how you get the two variables for number 17. Okay, let's do number 9 right here. Okay, we have to ask ourselves which trig function we're going to use. So we've got our 53. I have a, b. I'm going to find a first, so I'm just going to scribble out this b. That was the hypotenuse, by the way. So that means this 22, see how far away that is? That is my opposite leg. And this one, that's really close, is my adjacent leg. Opposite over adjacent. Once again, that is the tangent function. So I'm going to go tangent 53 is equal to opposite over adjacent, 22 over a. Once again, the variable is in the denominator, so I'm going to swap the denominator with the function. So this is going to give me a is equal to 22 over tangent 53. But I can just put that in my calculator, 22 over tangent 53. That is 16.6. Okay, so that is A. Now I'm going to go ahead and find B. Okay, so I can forget about that for a second. So if I'm going to find B, time to scribble out A. Okay, 22 is still opposite, but B is the hypotenuse. Opposite over hypotenuse. Guess what that is? That is the sine function. Opposite over hypotenuse. So I will say sine, notice I say sine, not sin, sine of 53 degrees is equal to opposite over hypotenuse. So 22 over B. See how the variable is in the denominator? Well, that is when I reverse these. So that's going to give me B equals 22 over sine 53. So B equals 22 over sine 53. 27.5. Okay, so that is how you find A and B. Alright, look at number 10. Let's decide which trig function we're going to use. We got the 39, C and D. just going to scribble out the D. Alright, so I've got C, and I've got this 37. 37 is far away, that's opposite. C is close by, and it's not the hypotenuse, so it is the adjacent leg. Opposite over adjacent. Once again, this is the tangent function. So tangent of 39 degrees is equal to opposite over adjacent, 37 over C. The variable is in the denominator, so I will do my reversing. So this is going to give me C is equal to 37 over tangent 39. 37 over tangent 39. That is 45.7. Okay, now it's time to find the other variable, D. So this time I'm going to scribble out the C. Okay, forget about that one. And so now I'm going to focus on the D. So I've still got the 37, that's opposite. But the D here is the hypotenuse. So I've got opposite over hypotenuse. That is the sine function. So this is going to be sine 39 is equal to opposite over hypotenuse. The variable is in the denominator, so I will reverse these. So that's going to give me D is equal to 37 over sine 39. That is 58.8. Okay, I think there's one more left. Okay, we've got E and F. So, alright, I'm just going to go in alphabetical order, and I'm going to find E first. So, looking at this 36, E is far away. So that is the opposite leg. Now this 2 radical 7 is close by, yes, but it is the hypotenuse, it's not a leg. So be careful to call this hypotenuse and not adjacent, because adjacent means adjacent leg, like the one I scribbled out, not the hypotenuse. So anyway, I have opposite over hypotenuse. Which function is that? That is the sine function. So sine of 36 will equal opposite, which is E, over the hypotenuse, which is 2 radical 7. Am I going to do the swap thing? No. You can only do that with the denominator. That will only help you if the variable is in the denominator. So how will I get this E by itself? I'm going to multiply both sides by the denominator. I'm going to multiply both sides by 2 radical 7. Okay, if I do that, these 2 radical 7s just cancel each other out. And what I have now is I have 2 radical 7 sine 36 equals E. Okay, it says 3.1. Okay, last variable. I need to find f. Okay, so let's uncover this. Let's forget about that. And this time we will do f. Well, f, see how close it is? F is the adjacent leg. I've still got that hypotenuse, 2 radical 7. So I've got adjacent and hypotenuse. Which trig function is that? I'll give you a hint. This is the first time this one has showed up on this particular assignment. This is the cosine function. Alright, because cosine of any angle is the adjacent leg. You know, I forgot I wanted to scribble this one out. Okay, we're just looking at these two. So the adjacent leg, f, over the hypotenuse, 2 radical 7. Okay, do I need to do some swapping? No, you only do that with the denominator. When the f is in the numerator like this, I need to multiply both sides by the denominator. So I'm going to multiply by 2 radical 7 on both sides. These 2 radical 7s are going to cancel each other out. So that's going to leave me with f equals 2 radical 7 cosine 36. Two radical 7 cosine 36. And that is 4.3. Okay, and that's it for this assignment.